Okay, so next we have Diana Cruz-Dávalos. Where are you? Okay, great. Hi, Diana. So she's a grad student, if I'm not mistaken, jointly advised by Maria Avila, right, and Ana Malaspinas in the University of Lausanne in Switzerland. And she's going to talk about a very attractive title, which is Ancient Brazilian Genomics.
Hello. Hi, I'm presenting today my first project in my PhD thesis. This is work under progress, so don't expect a lot. And yeah, I'm supervised by Ana Malaspinas and co-supervised by Maria Avila here. And in the lab, we are interested in the studying genomes of ancient and modern populations. And our current motivation is learning more about the peopling of the Americas. So the traditional model holds that the continent was peopled by a single population that just expanded in the whole continent. But recently this model has been challenged thanks to the study of genomes from native populations. And in our project, we are studying the Botocudo population, which is, there are some groups from Central Eastern Brazil. They shared some similarities regarding the language they spoke, their lifestyle as hunter-gatherers, and they used to wear some wooden discs on the ears and lips. But from a more a different point of view regarding how they were self-identified. They were different tribes and they had different names themselves. Botocudo is just a denomination by the Portuguese settlers. And most of them became extinct during the colonization period. The National Museum in Rio de Janeiro had some Botocudo skulls in their museum, and we studied some of these samples. Unfortunately, the museum burned down in September last year. So this is, we are maybe the only laboratory to have DNA from this museum. And before this tragedy, we collected 21 individuals. The samples were collected in these different states in Brazil. And we have this genome coverage. As you see, more than 65% are below 1X. And I didn't mention, but previously 2 individuals from this collection were analyzed, and they showed a Polynesian ancestry. So we first wanted to look if we didn't have more strange samples in our data set. So I ran a mixture analysis for the 10 best samples that we had. And here you see I have the African population, Europeans, Oceanians, Asians, and Native Americans. And our samples are here. So when we assume 5 ancestral populations, this is what the ancestry looks like. So the Botocudo group looks like Native American, and we continue increasing the number of ancestral populations to 6, 7, 8, 9. And what we observe is that we just observe ancestry within the Native American populations here. What is a bit surprising for us is that here I have 2 other Brazilian populations, Caritian and Surui, and this is how their ancestry looks like. So here they are in blue and orange, but here the Botocudo actually shows an ancestry that is more similar to that of Colombians. Even here, when we split in 8 populations, but then in 9 they form their own cluster. And well, this is also to see that there are not striking differences within the Botocudo population. And then the next thing I wanted to test is whether there was an ancient gene flow from an ancestral population related to Australasians, who are people from the Andaman Islands, New Guinea, Papua, and Australia. Because some recent studies have shown that a few Brazilian populations show a signal indicating that they received some ancestry from an ancestral population somewhere here. And what I have is something really, really preliminary. It's just to show you what I'm gonna do next. So we plan to do this statistic analysis. And so a reminder, this is the null hypothesis that I'm testing. I have an outgroup, and then we can know the derived and ancestral allele. So we can reconstruct phylogeny. Imagine if we have one site. And if I have the Papuan population here, and I have a Mexican population, the Mije, and then a test population, this is my null hypothesis, that this is the true topology of the populations. But if this statistic is below 0, then it might indicate that along the genome, I have more a scenario that looks like this, where my test population might have received some admixture with the Papuan. But if the value is higher than 0, then it's more likely that the Mije is more closely related to Papuan compared to this test population. So what I'm testing here is I'm using, you will see on the y-axis a population, and then I'm fixing the Mije, the Papuan, and as an outgroup I use the chimp. Again, this is just a quick test. And what I should observe is that Caritiana should be, for example, because it's Brazilian, should be closer to the Papuan, so below 0, but I cannot replicate this result due to, well, this panel is really small. I need to increase the sample size. Here I have one Botocudo sample, and I observed the same result. So I need to work a bit more on this. First, to replicate the result of previous works. And well, with this I will conclude. We don't have some individuals that are not Native American in this data set. And we also don't detect European or African ancestry in this Botocudo population. We plan to increase the genome coverage in these genomes and do the proper test to model the demographic history. And I want to thank my supervisors, the people in my lab, and all our collaborators. And thanks for your attention.
Great. Thank you very much. Congratulations on the presentation. We have time for questions. I have a quick one, actually. So I was wondering why you did not include the Surui population in your analysis that previously showed this small signal of the Melanesian component, but I didn't see it in your table of population. So I did see the Caritiana, but maybe not Surui. Is there any reason for that?
So why didn't I include which population?
The Surui, the Brazilian Surui.
So first, because this is like the first panel I got, I'm downloading more samples, and I didn't have the Surui. It's true the Surui has the strongest signal, but I didn't have it. Still, Caritiana should show the signal, but it's known that it's unlikely to recover the signal if you have just one sample. it's a very slight signal.
Okay, it's a work in progress.
Yep.
Okay, great. Any other question? Yep. Wait, just wait.
So you found what is expected, I guess, in the null hypothesis, where there is nothing strange on these samples. They are Amerindians. There is no signature of something unexpected. But what do you think about the previous publication where this was accepted, this was found? And I guess it's harder to get something published when you don't find something very strange and just what is expected. But do you believe the previous result? Do you think that there was a mistake in the sample or different individuals?
No, I just believe I don't have the exact same data set. So this is, here I have one sample per population. So I really need to increase the sample size here. No, I think what I observed is true.
All right, join me in thanking Diana. Thank you very much.